double check that with me, with what I've got. Is that what the problem reads that you have? Did I do anything incorrectly? Looks good. Okay, so this is 21 from yesterday's assignment, and we're going to work it through and talk about, because this is kind of a special inequality. So first step, what do I need to do? The first step, Abby. Distribute. I have two places I need to distribute, correct? So I'm going to do that. So negative 6 times 1 would be a negative, would be a negative 6. And negative 6 times 7k will be negative 42k. So there's my first distribution. And now I'm going to distribute the 7 through. 7 times 1 is 7. And 7 times 6k is a 42k. And then I have less than or equal to 2, negative 2. Does that look good? What's the matter? My voice is off of what?
No, your hand, like after you draw it, takes like 10 seconds.
Oh, yeah. Okay, so on the left, we're going to combine like terms. I have a negative 6 and a positive 7. What is a negative 6 plus 7, Tawny? Which is, do we have more? Do we have more positive or more negative?
Oh, it's a positive.
Positive 1. Good. So we have 1. And I have a negative 42k plus 42k. What does that give me, Caitlin? Negative 42k plus 42k. 0. So I have 1 plus 0. On the right, I have nothing to change, correct? So on the left, let's go one more step. What is 1 plus 0? 1. And I have no variables left. So now I'm looking at my inequality, and two things can happen. It's either going to be true or false. So I'm reading this as 1 is less than or equal to negative 2. Is that true? Is 1 less than or equal to negative 2? No, that's false, which means there is no value of x that's going to work in this inequality. Nothing will work. So what do we call that when nothing works?
No solution.
No solution. Or no solution. So in that case, we just leave a blank graph. There's no number on the number line that works, so our graph is blank. So I would expect to see something like that. The 0 with a slash through it, that's empty set, meaning there's nothing in the set of numbers that will work. We have no set of numbers that will work in this case. Okay? Any questions on that one? Let's look at the next one. If it doesn't turn out to be true, then I'll explain how we would handle a true inequality. All right, number 23, first step, Jasper, is to do what? Distribute. 3 times 1 is 3. 3 times 2x is 6x, but it's minus, so minus 6x. And I have is greater than 3 minus 6x. Okay, so I want to get my x's on the left. I want my x's on the left. So, Trenton, what do you think? Need to do something with this 6x over here. What am I going to do with it? That's 6x. Well, it's being subtracted. So what's the opposite of subtracting? Add. So in order to get 0x on the right, I'm going to have to add 6x. So I'm going to do whatever I do to the right, I do to the left of my inequality. And I have 3 is greater than 3 because the x's cancel out on both sides, don't they? Okay, so when the variables cancel out in an inequality, we're looking, is it a true or false statement? Is 3 greater than 3? 3 is equal to 3, but 3 is not greater than 3. So again, we have a false statement. So no solution or empty set. All right. So let's take a look at let's say we do some work. Everybody have that written down? Let's say we do some work, and as we do our work, we get all the variables cancel out, and we get -2 is greater than -6. Is that a true statement? Yes. Yeah, it is. Okay. So that means when the variables are canceled out, that means anything will work for x and give us a true statement. Whatever we plug in for x or the variable will give us a true statement in the end. So then our solution, we would say it as all real numbers. Have you seen that before, the big R? Everything works. And then on our number line, we would do this. We would just have a full line above it to show that every number on the number line would work in this inequality. Okay, so none of the problems that you've done so far have given you a true statement. If they were to give you a true statement, this is how you would handle it. You would say all real numbers, and the graph would be the whole number line. Everything on the number line. Okay. All right.